You are welcome. So we are looking at light, its introductory under optics, and some properties of light and how light interacts with matter. So let's look at the introduction of light. So light is a form of energy that is responsible for the sensation of vision. So light helps us to see, it enables us to see. And light is a part of the electromagnetic wave, so it travels as an electromagnetic wave. So if you take the electromagnetic spectrum, light is a smaller part of it which sensates our vision. So the spectrum is from radio wave to gamma rays, and light is a very tiny part of the spectrum which enables our vision. So this range of radiations are placed with their respective wavelengths and frequencies, and visible light is the only frequency at which the human can sense, or is the only wavelength at which the human can see. So the electromagnetic spectrum consists of different types of radiation, as I said earlier: radio waves, infrared, ultraviolet rays, visible light, X-rays, gamma rays, and the others. So all these radiations are in the spectrum, and only the visible light is the one that the human eye can see. Other animals or other species can sense the other type of radiations visible in the spectrum. So visible light is a very small portion of it at which the human can detect. Now, light exhibits some properties which help to classify light into it being a wave or a particle. So these properties are, they can reflect. So we know that light can reflect, it can refract, it can diffract, it can be dispersed, it can be polarized, interference can occur, and can travel in a straight line as well. So these properties help us to group light into wave and particle, and help us to give some specific properties of light as well. Now, it travels at a speed of 3 times 10 to the power 8 meters per second squared. So this speed at which light travels cuts across all the radiations in the spectrum. So all the radiations in the spectrum travel at this speed. All the radiations in the spectrum travel at this speed. Now, white light is a combination of all visible frequencies. So all the visible frequencies, as we know, as red, yellow, green, blue, indigo, violet, and orange. These are the visible frequencies. These frequencies combine to give us the white light. These frequencies combine to give us the white light. So if you look at this short video, white light is present to give all the visible frequencies, ranging from red to violet. So if you combine these visible frequencies or these colors, they'll give back the white light. So as you can see here, the main component of, or the primary colors, or the primary visible frequencies, which is the blue, red, and green, they combine to give the white light. The blue, red, and green combine to give the white light. So these are the visible frequencies at which we can see. Light ray is a directed straight line representing the path followed by the light. It's a directed straight line representing the path that light is followed. And a bundle of these rays is termed as the light beam. So a directed line which is straight, representing the path at which light is followed, is the light ray. Now, the color of an object is due to the color of the light it reflects or transmits. So for you to see an object, its specific color, then it is the ability of the object to reflect the color to you, or to transmit the color frequency through it, which help us to see the object's color. So materials through which light can pass in a straight line is termed as transparent. So materials that light can pass through without any obstacle or without any impedance is termed as a transparent object. And the material that absorb light without re-emission, or through which light cannot pass through, is termed as an opaque object, or an opaque material. So if the material can absorb all the light coming to it, or does not allow the light to pass through at all, is termed as an opaque material. And also the nature, behavior, and effect of light are reflection, as we've discussed earlier, refraction, dispersion, diffraction, polarization, and interference of light. So reflection of light. Reflection is the bouncing back of light of a surface when it hits the surface. So when light hits a surface and bounces back, that is termed as reflection. The light then changes direction after hitting the surface. When the light hits the surface and it is bouncing back, the direction at which the light moved towards the surface changes. The direction of the light changes. So the bouncing back of light is termed as the reflection. And reflection can happen in two ways. So if the surface at which the light is hitting is polished or smooth, and if the surface at which the light is hitting is rough or irregular, these can give different kind of reflections. So we will discuss them as we move along. So let's consider a plane mirror as the surface. So when light is reflected off a mirror, it hits the mirror at the same angle and reflects at the same angle at which it is hitting the mirror. So this gives us some principle or some rules that reflection takes place. Now this happens when the surface, which is the mirror, is a polished surface, therefore making the incident angle and the reflected angle the same. So when the surface is polished, it is smooth. The angle at which the light is hitting the mirror or the surface will be the same as the angle at which it is reflecting. Now, reflection happens on an irregular surface. And when such reflection happens, the incident and reflected angle are not the same because the surface is rough. The angle of incidence and angle of reflection will be different. So the reflection on a smooth surface is termed as specular reflection, and that of a rough surface is diffuse reflection. So specular reflection is due to smooth surface, then diffuse reflection is due to rough surface. So if you take a look at these two diagrams, the first one is the diffuse reflection from an irregular surface, and the second one is specular reflection from a smooth surface. So with this, the angle of reflection is different from the angle of incidence. All the angles of reflections are different from the angle of incidence. And with the specular reflection, the angle of incidence is the same as the angle of reflection because the surface is smooth. These are the two types of reflections that happens due to the surface at which the light is incidenting. So now there are some rules at which reflection has to follow. There are some rules, and these rules are the incident angle and the reflected angles are always the same. They are always the same. And this rule applies to only smooth surfaces. The second one is the incident ray, the normal and the reflected ray all lie in the same plane. So if you take the normal, the incident ray and the reflected ray, they are all in the same plane. So this is how reflection of light occurs, the properties and the rules govern the reflection of light.